All right, let's get right into it. We're looking at a critical security flaw, a zero-click, unauthenticated server takeover. And this isn't just some theory. It's being actively exploited in the wild right now. Let's break down exactly how it works.
So, what's going on? Well, there's a major flaw out there that's letting attackers completely seize control of web servers all across the internet. And I want to be super clear, this isn't a possibility, it's a real-world threat happening as we speak. This vulnerability has a name, CVE 2026-33032. So let's dig in and really dissect what makes this thing so incredibly dangerous.
Okay, first things first. We have to understand the core weakness, the design flaw that's at the heart of all this. It's really a story about two things: inconsistent security controls and a dangerously permissive default setting. Okay, so what you're seeing here reveals a really critical architectural flaw. The Nginx UI has these two endpoints for its model context protocol. Think of it as a tool for admin tasks. Now, the main one, /MCP, is locked down tight. It requires an IP whitelist and user authentication. But look at the other one, /MCP_message. It completely skips the authentication part. It's only relying on that IP whitelist. And that single inconsistency, that's the whole crack in the door.
And if you thought that was bad, this is where it gets so much worse. This quote right here from the official disclosure says it all. That IP whitelist, the only thing protecting that vulnerable endpoint, by default, it's completely empty. And you'd think an empty list would mean deny everyone, right? Nope, it fails open. It treats that empty list as a green light for the entire internet. It's literally the perfect storm for an attacker. So, to put a formal name on it, this is a textbook case of CWE 306, missing authentication for a critical function. It's one of the classic, most severe kinds of security oversights you can find. A function that absolutely should be locked down is just left wide open for anyone to use.
All right, so we've seen the flaw. The big question now is, how does an attacker actually use it? Let's walk through the exact sequence that takes them from the outside to a full server compromise. But first, let's be crystal clear about the impact here. We're talking about a CVSS score of 9.8 out of 10. That's about as critical as it gets. It means a total compromise of confidentiality, integrity, and availability. In simple terms, the attacker can read everything, they can change anything, and they can burn the whole thing to the ground.
The attack itself has been nicknamed MC Pawn, and honestly, it's just dangerously simple. There are no complex exploits here. It's a four-step process that requires zero authentication. An attacker starts a server-sent events, or SSE, connection. The server, without any checks, just hands back a valid session ID. With that golden ticket in hand, the attacker sends their malicious command straight to that unprotected /MCP message endpoint. The server just accepts it, rewrites its own configuration, and reloads to make the changes live, instantly.
So once they're in, what can an attacker actually do? Well, they get access to 12 of these powerful MCP admin tools. And get this, 7 of them are destructive. We're talking about the ability to read and steal sensitive configs and credentials, inject malicious routes to hijack traffic, or just flat out delete files to cause a denial of service. And the real kicker? They can trigger a reload anytime, so their malicious changes take effect immediately.
Okay, so let's zoom out and look at the real-world scope of this problem. Because again, this is not some theoretical exercise. This is live, it's happening right now, and it's on a global scale.
Just how big is the attack surface? Well, internet scans have already found over 2,600 Nginx UI instances that are publicly exposed and likely vulnerable. That's a huge number of potential targets, with most of them sitting in places like China, the US, Indonesia, and Germany. And this timeline really shows you just how fast this whole thing blew up. Look at this. Exploitation was already happening in the wild before the vulnerability was even discovered and made public. Researchers at Pluto Security found it on March 14th, but by the time the official CVE and proof of concept code dropped on March 30th, the bad guys were already way ahead of the game.
So this all leads to the one critical question every admin should be asking right now. How do I know if I've been hit? So let's shift gears and focus on some actionable intelligence, things you can use to hunt for this threat in your own environment.
Okay, here are the big telltale signs you need to be looking for. On the network level, you're hunting for any weird post requests to that /mcp_message endpoint, especially from external IPs that shouldn't be there. On the file system, you need to be watching for any unauthorized changes to your Nginx config files. And finally, in your logs, be on the lookout for Nginx restarts or reloads that weren't scheduled. That's the sound of an attacker applying their malicious changes.
All right, now for arguably the most important part, how do we fix this? Let's break down the strategy for both immediate containment and the permanent fix.
Okay, for immediate damage control, your first move is to enforce a non-empty IP whitelist. Lock that endpoint down. If you don't even use the model context protocol, just disable it entirely. And a great practice is to put the whole UI behind a VPN or an authenticating reverse proxy. Now for the permanent fix, you absolutely have to upgrade to Nginx UI version 2.3.6 or later. And please, as a golden rule, never, ever expose a management interface like this directly to the internet.
And you know, this quote from the CEO of Pluto Security really nails the bigger lesson here. As we all rush to integrate new tools, especially AI, we're adding these new endpoints, right? The problem is, these integration layers have all the power of the core application, but as we just saw, they often completely skip the same rigorous security checks. They are an absolutely critical and often overlooked part of the modern attack surface.
So the final call to action here is clear, it's urgent, and it's 3 simple steps. Step 1, isolate. Right now, restrict all network access to your management interfaces.
Step 2, hunt. Go back and actively look for those indicators of compromise we just talked about. Check your network, your logs, your files.
And finally, step 3, patch. Upgrade to the latest secure version and slam this door shut for good. You need to take action on this now.
And we'll leave you with this thought. We just broke down one very specific vulnerability. But the pattern is universal. Now that you've seen how one single missing security control can lead to a full takeover, how are you going to audit the integration points in your own applications? What's hiding in plain sight in your own infrastructure?